שלום לכולם, הרצאתי באנגלית. אפשר להתחיל? אוקיי, hello everybody. איך אנחנו נכין את זה? Okay, hello everybody. My name is Gil Mazuz. I'm the head of front-end at NSO Group, which is a cyber company, the leading cyber company. What I'm about to show you right now is a presentation that shows functional reactive programming. Functional reactive Flux, actually. I'm going to display the architecture that we've used after a lot of research, honestly, and we're quite content from this architecture. So let's begin. So first of all, the first thing that we should know is what functional reactive programming is. We hear about it so much. Rx.js is a library that implements some of those principles of functional reactive programming. Functional reactive programming is all about streams, all about observables. Streams, you can look at them as, instead of data over space, like you have in arrays, it's data over time. For instance, let's just say I have an array, okay? Array, for instance, with the numbers 1, 3, 5. I can do today with JavaScript, I can do map, reduce, and filter. Map, reduce, and filter. One, two, okay. Okay, בסדר? Okay. רואים את המספר? Okay. So, for instance, we have an array with the numbers 1, 3, 5. We can do map, reduce, filter. We can use functions over this array and get a new result. Now, this data is over space. We have this data right here and right now. A string will be having the first item, for instance, right now. I can get number 1 right now. Number 3 can come in 2 hours. Number 5 can come in 5 hours. It's asynchronous, okay? You get the data, but you don't have it specifically right now. But the beautiful thing is that you can do all of those functions that we have in arrays over this collection, over this stream. So what you actually define is a flow, is data flow. You actually define what happens when you get data and what transformation are going to be on it. So, why do we need all this thing? Why am I talking about that? I'll give you a very simple example and then we'll get to something more complicated. Let's just say we have a normal variable and I'm doing an assignment of 5. Now A equals to 5. How much B equals? Can anyone tell me? If it equals to 2 multiplied A, how much is it? 10. Right, it's 10. Now someone in my code, a friend of mine, just put A equals to 8. He's done an assignment of 8. How much B is it? How much B? 10. Is it? It's still 10. But for me, I would maybe expect that B will be right now 16. But it's not, because it's not reactive, it's not changed, it's not updated according to the new change. Now, for instance, stream A, let's just say the syntax is observable of 5. It's equivalent of A equals to 5. When I put stream B equals to stream A, dot map A to multiply A, the stream B cannot be modified here anywhere else, which means that stream B right now, I just defined all of its behavior, all of the ways that this stream can change. And that's a great thing, because I know for sure that no one can change my stream B right now. This stream B will equal always the dependency of A. So, what's this reactive word? We say functional reactive programming. We know, I mean, some of us probably heard about functional programming, about pure functions. But what is reactive? Well, let's first begin with what we all know, which is interactive. Interactive, we have, for instance, a module, foo. And right now, he is a proactive. He is operating over module bar, and he's operating over module Quix.js. Now, how does it happen? This is how we all know that. Bar.js right now exposes functions, public functions that everyone can use. Now, and also Quix.js also exposes functions that everyone can use. The only problem here is that if I would like to see who changes bar, I will have to look for the entire module of the system to see who is operating on my module, who is trying to change bar.js, because everyone can change it. Everyone with an access to the global function, to the public function that bar.js exposes. Now, in control-wise, because by the way, bar.js is called passive because everyone operates on it. Also, Qjs, for instance. And Foo.js right now is the proactive because he's operating over bar.js. Now, reactive is exactly the opposite. Bar.js listens to Foo.js, but bar.js, the only way bar.js could change is by changing himself. He's independent, and that gives us the fact that bar.js, if I read the code of bar.js, I know all of its dependencies, and that's a very strong factor. If I'm looking at bar.js right now, and I'm looking what happened, I can actually know all the influences, all the behaviors, all the changes that bar.js can have, because I know it's only reacting to changes, for instance, in this case, for Foo.js. And the same thing about Qjs, as you can see, is being changed by Foo or by bar, but it's only internal. It's only reacting to changes here and here. That gives us a very strong dependency tree. I can actually see a stream and see all of its dependencies. Let's see how it helps us. So, I'd like to tell you first other alternatives that we've tried. Some of them use Rx.js, some of them you probably know. And I'll try to explain why I didn't like them and why we didn't like them. First of all, vanilla Flux. We all know probably vanilla Flux. The problem with vanilla Flux is that, well, it's too much. It's a lot of boilerplate. You have to write so much code, and then you have all those wait for and synchronizing between stores and things like that that makes you feel really uncomfortable, and you're starting to think, okay, is that what I really want when I'm architecting my software? Then we've tried Redux. We all know Redux. Redux also suffers, in my opinion, from too much boilerplate. And it also, I don't like the middleware part of it. I don't like the monkey patching of dispatch. And again, too much boilerplate, but the reducer idea is cool. Then we've tried Cycle, Andre Stahl's framework, if you've heard about it. Now, Cycle is actually an interesting framework, I would say that. The problem with Cycle is that it's very good for counter examples. You know, we all like those counter examples, but when you go and you're trying to scale up, it doesn't scale. It has some notions that are peculiar to it. For instance, the fact that a module can expose not just, for instance, a view that listens to them, but also a stream of data. So if you'd like to share data between modules, it becomes a problem. And there are other problems that we've encountered. Another thing that I don't know if a lot of people know is React Combinators of Manuel Anakin. That's actually a very cool library. That what it does, it allows React components accept streams, not just properties. Now, that's really cool, but the only problem is that it's very intrusive to React. I don't like when you change a library because you might miss a lot of stuff that the library gives you for free. But actually, React Combinators was a very good idea. Yeah, it was a pretty good idea, but we didn't like it eventually. So, what's our architecture? So, we all recognize this flow, or most of it, from Flux. We have actions. They go through the dispatcher, then the stores listen to those actions, and then the view will get the data from the stores. We have user interactions and we have services. But let me explain to you how we did that. So, actions. First of all, every part in this architecture is reactive, which means our actions is actually a stream of actions. So stores listen to those actions, and Vue is subscribing to those stores, and user interactions are also handlers that making actions over the dispatcher, and everything is reactive. So what are actions? Things that happen in the outside world. Everything that happened in the outside world, and it's in a past tense. For instance, let's just say a user wanted to do something. Let's just say a user wanted to request a record. So we'll have a record requested. Let's just say an administrator tried to do something, clicked on a form, and we can have user created. It's composed with type and payload. The type of the action and the payload itself. And what it actually gives us is a unified language for all of our application, and that's a very powerful thing, because now I have an interface between all of my modules from the outside world that I could communicate with my application. By the way, this also works server side. I can also send actions from the server, and my application will respond accordingly. And I'll show that next. So, for instance, here we got examples of actions. Okay, we got game restarted, game started. We're gonna see a game later on, so that's actually taken from there. Okay, next, the dispatcher. The dispatcher is the gateway. From the outside world to our app. We have a lot of things that are going on in the outside world. For instance, we have WebSockets we have WebSockets and streams that are getting from the server. We have AJAX calls. We have user interactions. All of those imperative things are going through the dispatcher. It's an interface between the imperative and declarative world. Now, all of the inside of our applications, the heart of our applications, the stores are observables, are actually streams that we manipulate with functions. We operate with functions on them. So, but we do need an imperative part. Why is that? Because in order for something to happen, we need an imperative part. When I'm using a handler in React, for instance, on click, do a handler do something, it's imperative. That's the way it works. I have to have some imperative gateway. The good part is that this is the only imperative gateway we have in our application. It's stateless and it's centralized. We have one centralized place. This is called the subject. In Rx.js, subject is a very special stream. While usually a normal stream, as we've seen before, is defined once, and all of its behavior and all of its dependencies are only in one place. Subject is a different case, because subject you can actually push data to it. That kind of breaks all of the cleanness of the normal stream, the normal observables, but that's the way to do a gateway between imperative and declarative. So we can find that to a very specific place. Subject is actually a place that we push actions to it, and then from here and now, we have observable of action. That's all. We only can listen to those actions. So that's the dispatcher. As you can see, we're putting specifically here, action dispatcher as observable. Publish, replay, and ref count is out of the scope of this lecture, but in a word, I would say that it only makes everyone listens to it at once. It's making it a hot observable. Now, as observable, as I said, is to prevent for someone to try to push data to that dispatcher. There's only one way that data can get into our application, and that's via actions, the unified language. Stores. Stores are actually the heart of our application. Those are pure streams, decision makers. When I taught that to my team, I actually called that the CEO. This is the CEO of our application. State managers. Now, what they actually do, well, they preserve a state. They preserve a state through scan, which is an operator in Rx.js that is similar to reduce, only asynchronous. And what they do is they get an action, do a pure function on it, and it emits a new state. That's all they do. Now, the good part is that they always get action with full data. Actions always come with full data. So they just decide. They just get something, get action, and decide, okay, what's the next state? Those are state machines. Now let's see an example in the code. We have, for instance, color. You're going to see that again in the game. So we have, for instance, new pattern, switch map to color, map this color to observable off color, delay game speed. By the way, this is an animation. That's observables that allows you to have animations for the color. Then we can count all of those animations, and that's the stream. We have a stream of colors with animation. The most important thing to understand about store that they are pure, they're using functions, and they are actually our stakeholders and state managers. Another thing to know is that they also prepare handlers. Now, the reason that we put handlers in stores is because we like that the view will be dumb. We don't have smart components. The view is completely dumb. He only receives handlers. He doesn't know what he receives. He's got on click, for instance. He's getting a handler from the root, and he doesn't know what he's doing with that. He just knows that, okay, I need to operate on that. On click, I need to use that handler. But the handler is managed in the store. The view. Components, as we all know, React, stateless. At least we're trying to make it stateless. And parent takes care of child. That's very important. That's a very important notion, because what happens is that we always pass the prompts from parent to child, but the parent only take care of his first level of children. After he finishes, that's all. It's going on through that tree. So, as you can see here, that's a normal stateless component, as we know in React, a function that receives props with color, and it's getting it here in the style. Now, after we finishes all of this, how this thing goes to the rendering? Until now, we've just used functions. Views are also pure. It's just a function that receives data. F function of state equals to view. Here's the part that's doing the side effect. We're taking the up store, which is the combined latest of all of our stores, to one big up state. Taking this up state, doing spread, and putting it in the root, which is app. And from here on, every component takes care for himself and for his children. For his children first way. User interactions. User interactions are normal handlers, okay? What they do, they dispatch actions. We take them from the stores, and that's the way for a user to operate on the system. When a user, for instance, click on something, the only way for him to approach the system is by action. So that's exactly what he does, dispatches actions. So look, add row, for instance. This is a very simple example, but what he does is dispatch actions.row added. That's what he says. He says, when someone clicked, whatever, on click, if this is the handler, it's just going to dispatch row added, and whatever happens, happens. It makes it very simple because you only take care for yourself. Every model takes care of himself. Services. Services are a very powerful thing because we just said that everything is a pure function. Just to remind you, pure functions mean that you get a value, you don't use any side effect, you don't take it any state from any other place, you're just doing a transformation of this value and returning that value. But we do need side effects. We do have servers, Ajax, WebSockets, we have the view, by the way, which, as we said, goes eventually to a side effect, which is rendering to the screen. So services is exactly for that. Services can listen to actions and can dispatch actions as well. So streams, they're responsible for side effects. They can listen to actions, as I said, and they can dispatch actions. And the reason for them is to do things that we don't want to put in the store. A very normal use case will be, let's just say I'm trying to load users, okay? So the user clicked load users. An action was sent via the handler. The action was users requested. There are two modules that listen to this action. The stores that will probably emit a state of is loading for the view to show, you know, the busy indicator that we all know. And there's another module that listens to that, which is an AJAX service. And this AJAX service takes that user requested action, maps it to an AJAX call, receive the data of the users, and then dispatch users received action with the data, with the payload of the users. So it dispatches it, and then the stores listen to this, and then the stores listen to this action, take this action and do with it whatever, well, probably add it to an array that they hold with all the users, and the view will present those users, those new users. What we have is a clean flow. All the side effects, all the data that was needed to be provided is not by the store. The store does not provide data. He's a CEO. He has workers for that. Those services do that. Those services do that. So, an example for that, very nice example by the way, it's a push history. We don't use React Router. The problem with React Router is that it works view first. Our approach is always state first. You always go with the state. The state is the main thing in your application. A view is only a function of state. So the main thing is the state. So if we'd like, for instance, to listen, to change and to reflect it on a URL, for instance, so look what happens here. We get a dispatcher and we're listening to actions route change. We're taking this route that we've received and we're doing a push state to the history API. So what we do is changing the URL after listening to this action. So this is a side effect. That's happened also in a service. So as we said, side effects could be DOM, HTTP server, WebSockets, Logger, Exception Manager. By the way, Logger is also a service. It's a very simple service. You're doing dispatcher, subscribe, console log, that's all. You just log in all the actions, and by that you open your entire application. You can see all the actions that go through the dispatcher, through that one place. And you can see everything that happened in your application because that's the only way to change it. By the way, including the server-wise. So anything that comes to your application goes through that, and you can log, and you can just watch it. The pure part is, as we said, store and view. Now, as you can see, what we get from this is data flow. Data flow opposed to, I would say, control flow, or opposed to normal usage of classes or controllers or view models that you need to handle, and you need to handle the dependencies between them. Here you have a clear data flow, A, B, C, D. And I'm saying that, and that's exactly how you think. You're thinking, okay, I have a new feature to enter. What do I need to do? I have to do, first of all, which action I'm operating on, which action I should. After I do the action, how the store listens, what does it do, how it reacts, what the store specifically reacts to this action. After that, what the component that I'm showing, and so on. If we have a service also in the middle, we put that also. So the advantages, as I said, simple mental model, very simple mental model. It's not necessarily easy. It might take some time to make all the preparations, but once you get it, it's simple. Simple versus complex, by the way. I highly recommend Simple Over Easy of Rich Hickey presentation. If anyone would like to see that, it shows that principle very well. Event sourcing. Because our stores are pure, and because they are actually function of actions, we can actually know for each state all of the actions that led to this state. That's also a very powerful thing, because we know what happened. We can retrace all of those actions and get the same state, because those actions with the same data are pure. There are no things in the middle. And clear declarative flow. The disadvantages, and there are some. It's a very high learning curve, because RxJS, and by the way, a very important comment about that, we are using RxJS and React, but we could have easily used any other stream library, such as Kefir, or Bacon, or Xstream, and the same goes about React. We could have used SnapDOM or VDOM. Our approach is libraries over framework. This is not a framework. This is only a pattern. This is only an architecture. And that's a very important thing because we prefer this approach. So, the disadvantage is high learning curve. It's a mind bender because you need to think in a different way. Instead of thinking in an imperative way, which is do A, do B, do C, and so on, you're starting to think in flows, in data flows. Because time is not a factor here. Because, as we said, when you define a stream, you define all of its behaviors in one place. So you need to think, okay, I've got the data, what are all the transformations, what's the next stage, what's the next stage? You put it once and that's it. It's like a machine. I wouldn't really compare that to an industrial machine. It's very similar. You have like a line that runs and the products go through it. Now, debuggability, to be honest, is not amazing out of the box. It's not amazing out of the box because it's asynchronous. It's not that easy to just put a breakpoint and see your stack trace or to see your call stack. But, however, as I said before, because we have only one dispatcher, only one gateway, only one subject, and we can put a logger on it, a logger service that listens to it, it becomes a little easier to debug and to see what happens in our application. So, 1 second, yeah, it's a gate path. So what I'm going to show right now, I'm asking for everyone with Android phone to please put the URL cnc.org.il, and everyone with iOS, please enter through Safari and not Chrome because we have a little bug. Now, our sponsor from my team developed this game, and it's based on this architecture, and I would like to show you. So, please put your username. You'll see something like that. A username and the nickname. Now I'm gonna show you how things are running while we're starting to play this game. So please enter your users. Now this game is very simple. You're gonna see a pattern of colors. And you need to press on the right colors in the right order. And then you move to the next level. Now the good thing is that there are results, as you can see. And you can see who made it to, to the next level. So let's begin. Okay, we have already 8 failed users. By the way, I'd like you to see all of those actions that are running. All of those actions that are running through. Everything in the WebSocket that comes. Stat update. We can actually get and see the data here. That's the beauty part about this because we have all the actions, all the log is just in front of us. We can actually see our applications is open right now. So right now we have Yaron in the first place. So let's go. Let's end this level and go to the next level. It's going to be a little bit harder now. Okay, so, okay, we're about to screen you all. As you can see now, we have, for instance, pattern timeout. We have pattern activated, pattern added. We can see pattern added. We can actually, if we see the data itself, you can see exactly which pattern was added and so on. So, next level. I already forgot, but you probably have better memory than I do. I know the age. So, we have only 5 contenders, so we'll go straight to the next stage, next level. Okay. Oh wow. Well, we don't have anything.
It was a bug. Manipulate your shot.
All right.
Just restart the game.
Restart the entire thing?
Yes. Yeah, everybody got time now.
Okay. Okay. I need a restart. Anyone who missed?
I can restart the game.
All the actions are here. You can actually emit the action with a pattern, and you can cheat if you'd like. Right now it's over. Still no, nothing? Do you see the pattern? Everyone sees it? All right. End level. Time out. Okay, I think the concept is okay. You're all winners. You're all winners. So, let's go on. Now, yeah. That if this is your face after this presentation, I urge you to read a little about functional reactive programming, about RxJS. What we did with our architecture is actually after a lot of research, because we've searched for an optimal architecture that allows us to insert changes and insert features with minimal effort. Now there is no perfect architecture, but that's quite good for us. Now that leads us actually to MobX. Recently we've started to use also MobX. Now what is MobX? Michel Westrick, a very nice Dutch person, Dutch guy, that made it, probably didn't like to work too much with streams and Rx because it was, I don't know, too much low level for him. And he decided to make it a lot easier to do functional reactive programming. And he used something that calls TFRP, which is transparent functional reactive programming. In other words, just use the JavaScript you know, just use the normal code, just use the normal code you know, and magically things will happen. I'll explain. It's supposed to be simple and scalable stage manager. It's working like Excel, which means in Excel you define a formula, and when you change a cell that the formula responds to, reacts to, everything changes automatically. You don't need to change it manually. So the same thing here. What we do in our architecture, we could actually use this in the end of the line, because as you see, we have an up state. This up state could be MobX, observable, and then the React view will be an observer, and it could be it could actually be an optimization for performance of rendering. So let's show some code, for instance. If it reminds you, by the way, a little bit of model view model, MVVM, or things that you know from the past, well, it makes sense. So we have, for instance, class to-do list. We have observable to-dos. Look, it's only a decorator that you put here. And by putting that decorator, what you actually said that this to-dos is now observable. Every change for this to-do, now some other parts can register to those changes, can change automatically when to-dos change. Computed is a dependency of to-dos. Computed is a lazy dependency, so when we have unfinished to-do count, when to-dos change, this will change, but only if you look for it. Only if you look for it, it will change. This is a getter, simple getter. And also with a decorator of computed. That's supposed to be a pure dependency. Observer is a reaction. Reaction is exactly the side effect. It uses MobX React, and it listens to changes in to-dos and automatically re-renders the state. Now, all of those things are happening because the main problem is we're being told that React is function of state. Function of state equals to view. That's the purpose. But something that they forgot to tell us that the state is dynamic, but no one knows how to change it. And then comes Flux and Redux and our architecture as well. And MobX do that the same. MobX says, okay, I like this state to be dynamic. So every time someone changes this state, my components will react to those changes. So, and we have also very good optimization for rendering. We don't need should component component update. We don't need pure rendering. We don't need all of that because what it actually do under the hood is the force update specific for a specific component when a state changes. So that's MobX. That's how we could use it in our architecture. If you have questions, this is the time. Yes.
I read that Michel, the author of MobX, said that it's not really good for an append-only model.
To what?
To append only domain model. If your domain model has a lot of, I don't know what the הוא אומר שהמובקס סטור, החולשה שלו זה כשאתה עובד במודל של append only. הציטוט שלו.
A weakness of MobX itself? I think that where MobX has some disadvantages, one of them is that it's only reference oriented. If you change value, you won't see those changes. Only when you change reference. You have to change reference in order to see the changes. So if you have value, you need to box it. You need to do a wrapper on it just to see the changes. So I don't know if that's what you mean, but yeah, this is one of the disadvantages of MobX. It's not perfect. And I think, well, MobX itself is a very nice library. It's a very nice library. It allows you to do state dependency, state management very well. And very easy, because you can just write JavaScript and things will work. You just say, this is observable, this listens to that observable, this is observable, this is a reaction, and things are connected. However, if you'd like something more powerful and to do functions over those variables, streams are more appropriate, in my opinion. Yes?
הצגת את הדיספאצ'ר בצורה שלא מתיישבת לי עם ההגדרה שלו בפלאקס קלאסי, בגלל שבפלאקס הדיספאצ'ר מסנכרן את האקשנס.
מסנכרן את
כן, ובמה שאתה הצגת פה יותר להזכיר אקשן קריאטור.
No. So I was probably misunderstood. No. The dispatcher is actually a stream of actions. That's what it actually does. The only thing, that's why we call it dispatcher, that you can push actions to it. But once you push actions to it, that's it. It just dispatches those actions.
זה במימור שלך, אבל בגדול אתה מחצין API מסוים ויוצא ממנו actions, שזה action creator.
No, those are not action. No, this is not action creator. The action creator is the dispatch. The dispatch action, that's the action creator. After I do dispatch, that's it. An action was emitted already. And everyone can listen to it because you already have a stream of actions. The dispatcher has two sides. That's a good question. The dispatcher has two sides. A side that the action goes in and the side that the action goes out. The side that the action goes in is one function. Only one function that can push things to it. What it actually does is subject.next. That's what exactly in Rx. So this function calls dispatch. This is our action creator. On the other side, it's just an observable of action, and everyone can listen to it. So it actually has two roles, in a way. But yeah, it also has action creator, which allows to put actions inside of it. And yeah, yes.
זה מגיע לספצ'ר, יש בכל מקומות אנשים שמאוד מסורים יותר שמאזינים לו, ומגיעים לזה לטק סטייט משתנה, ויכול להיות גם סייד אפקטס. אם אני עכשיו עובד במצב כזה, איך אני פשוט לחפש בפרויקט מי מאזין לדבר הזה?
No, that's a great part. It's very simple. Because, first of all, when you put a log, you can actually see how the action flows. Okay, you can see where the action moves. No, even okay. If you're looking at the code, the pretty part about that, if you'd like to see who's listening to users requested, okay, you just look. Okay, that's a good question. This is a disadvantage of reactive. If you would like to see who's operating on something, you do have to look in the entire place. But that's not a problem because the most important thing is, if I'm looking at a module, for instance, an Ajax service, and I see that it listens to users requested, I can see all the way that it could change, all of the things that it listens to. That's more important to see who's acting on it. But if you'd like to see who's acting on it, and I got a question like that before. Yeah, if you want, you can pass the sender through the payload of the action. You can pass the sender through the payload of the action and look at that, but I have to. Okay, I have to say that's actually not the common use. I think that the bigger problem when you come to code and when you come to put a change is not to be afraid. Because when you see a module, for instance, a store of I don't know, users, you want to know that every change you put, you don't gonna screw something up in the system. But when you know that this is the only place I can change users, it calms you down. If you know what I mean?
One second, excuse me.
I don't know what happened. Actually. Sorry. Yeah, yes, yes.
Maybe I want to say, how you have, for example, a user created, I want to know exactly everything that it does. It's going to change the state, there's going to be 2 side effects. How do I trace that in the code? That's what I need to answer. How do I create the action?
You will have to do Control-Shift-F and find the user created. In a way, yeah, but
all the users that listen to it already.
You need to see who acts on it. Yeah, who listens to it. You need to see who listens to it because you know if I'll show you this look, if I like to see QJS what models is being influenced, I have to look here, here, and here. This is the inversion of dependency. So yeah. Any other questions? We don't have time? Yeah? Last question. Okay, yeah.
What's the difference between Flux and MobX?
Okay, this is not in the scope, but I can tell you a few words about that. Okay. No, I can say. MobX, that's very simple. MobX have a very, very specific flow, and not MobX, excuse me, Redux has a very specific flow with actions and one store and reducers and all that. That's Redux. MobX says, listen, I don't care what happens. You're gonna declare your dependencies by yourself. Just put an observable decorator over this variable, and that's it. You can go to sleep. Everything is gonna be okay. Every change in this observable, JavaScript change. Not immutable change, by the way, but immutable change, like assignment or push or whatever you would like to do. Everything will react accordingly automatically. So if my state is observable, and my component receives this state, that's it. That's all I need. It makes it more simple, and it makes it more easy to just, start things up. You don't need all the boilerplate. I think if you use it for this specific usage of optimization, it's okay. If you're starting using it all over the place, and you're losing the pattern of Flux, I think Flux is a very powerful pattern. It's very rigid, but the rigid is a good thing. Because the fact that you can need only actions, specific actions to do that, it's a very powerful thing. One word to say about MobX though, that it does have actions, different actions from what I said, which are functions that you put decorator on it, and they also have a new strict mode in version 2.2, which allows you to make sure that this state will change only if function has a decorator of action on it. So you cannot change the state elsewhere. The only problem is, that I've seen that in the code, that everyone puts decorator action everywhere. So the strictness goes away. So, yeah. Yeah.
איך אתה, ראיתי בארכיטקטורה, איך אתה מתמודד עם עבודה על שינויים שכבר קרו בסטור?
Okay. First of all, in the previous project that we've done...
אתה צריך לסובסקרייב ישירות על הסטור ושלהתמודד עם שינויים בתור after effect.
You'd like to see like the past, what happened in the past?
לא, לא רוצה לקראת את הפסט.
So?
אתה מעביר אותי אנגלית בזמן, לא שגרם בעבר. לצורך העניין יש צרכים שאתה לא יכול לענות עליהם בפלואו של האקשנס. אתה רק רוצה שאחרי שכבר מידע יתעדכן בסטור, להיות סובסקרייב ישירות עליה, ולהציג איזשהו שינוי בעקבות זה.
מה למשל?
בקייס מסוים זה שאתה למשל... אוקיי, אתה לא רוצה לעשות דיספאצ'ינג של אקשן בעקבות שינוי שכבר היה בסטור, נכון? הסטור לא אחרי אותה לעשות דיספאצ' של אקשן.
Store cannot do dispatch of action.
בדיוק, שמחזיקה state מסוים.
So you'd like to delegate an action later on? That's what you're saying? That's very simple. Because the handlers are inside of the store, it can pass this handler, which is the actual action creator. It has the dispatch on it, dispatch action, but this is the actual action creator, the wrapper, this handler. And you can pass it on to whoever would like that. And a view, for instance, and that's the way you can postpone an action after something happened. That's one way to do that. But that's a very good question as well. Yeah. No, I'd love to answer something else.
אני חייב להגיד שאני מנסה להבין מה אני מרוויח מהארכיטקטורה הזאת, לעומת שימוש ממושמע ברידקס, תוך כדי באמת דברים מבוססים מינימום.
I'll tell you exactly what your biggest gain is that we're not a disciplined person. The thing is that streams and action, the way we've done that, it's very hard to make mistakes because when you know that you have a store is a domain model, a domain place that you put, and you have streams that are dependent on other streams, you know that all the changes that this stream could have are here. You cannot fuck it up. You cannot change it. We've tried. We cannot do that. We've actually, a small story, we've done time traveling in the previous project we had, and we've done an adapter service that connects to Redux time traveling. Works with our architecture. Now we've tried to do things like injecting state and ruining stuff, but the architecture didn't allow you to do that. There's only one way to talk, and that's through the actions, and the store listen to action, and you cannot do this thing in the middle. And by the way, the time traveling worked. We have time traveling in our application. You can see that because you have a stream of all of the actions and stream of all the states according to those actions.
עוד שאלה, החולשה הכי גדולה של רידקס בעיניי זה זה שהיא אוכף עליך לעבוד עם סטייט נורמל. כלומר, אתה לא מחזיק את הסטייט בצורה אינטואיטיבית, ומוביקס תפרגן לך, תחזיק איזו צורה אינטואיטיבית של סטייט שאתה רוצה.
That's true. I haven't mentioned that due to lack of time, but yeah, we don't have any restriction about the state structure because the thing is, well, we do need to do it's preferable to do inside of the stores immutable actions, immutable mapping, I would say. Because it's more functional, it's more clean, and it's not that hard, really. It's not that hard. It's not that big of a deal to do immutable changes. Now, it's better, for instance, for time traveling. If you do time traveling, by the way, with MobX as well, if you do imperative changes, you're going to lose the time traveling unless you manually record all the state. But you don't have to do that in our case. And about normalizing, we don't need to normalize anything because the thing is, we just have a stream of data. We just listens to it in the view, just subscribe it, and React subscribes to it cleanly. We're not, this is a very important thing, we do not mess with React. We don't touch React. React is just a subscribe. Just a subscribe for the app state. Yeah, you wanted to ask a question?
Yeah, I have a question about, you mentioned time travel and there's only one way to change state.
Right.
So, okay, let's say I have some sort of an end state. For example, I have a button, which is something that I can easily do with Redux. I have a button, submit state as a bugger for it. Then, for something like Redux, I can simply set state, and I get the current application state, the entire state, to reproduce the button. So you mentioned that event sourcing, that means you have to replay the entire history, right?
That's a very good question. We've actually encountered that problem, but that's not a problem, and I'll explain exactly. Time traveling, it's like, did you see the movie Time Cop? When you go back in time, you cannot change anything. You cannot touch anything. So what we've done is actually read-only mode. When you go back, you cannot change the state. Because if you're changing something, that's it. There's a new state. You can only see it, okay? We do have a pair of action and a state that happened is due to that action. By the way, because in the stores, it's synchronous. That's a very important thing to say. It's synchronous, exactly like MobX does. So, only after you got to the latest state, that's the only place that you can start operating on it again. That's the way we've done it. But we don't have time traveling that you go back and start doing whatever you like and changing the future. You cannot do that in our
Yeah,
application.
but you can load an end state. You
can load an end state by injecting it through an action. We did actually a specific special action for that thing.
You can do that.
Yeah, we did that specially for the out state itself, but this is an action only for
It's like an escape hatch.
Exactly. Although the good thing is that the architecture by default does not allow you to do things like that. Let's think about a new pro developer that we see. Last question for real? Or not? Enough time? Yeah, no, I'll do my things.
כשעברתם למוביקס, אתם הפסקתם להשתמש ב-Rx, שזה מתמזג ביחד?
Oh, that's also a very good question. We started a new project just with MobX and with a pattern very similar to classic MVC and DVM, I would say more. With one-way binding, not two-way binding. And I have to say that I miss our architecture. I miss it because we've done that in the previous project and it was great. They can be combined together. We did not do that in this project. We can use it, we can combine the both. I think they can play very well together. And I think Rx that's in my humble opinion, I think Rx is much superior to MobX because it gives you a lot more power. You have streams, you have functions, very strong operators. You can do amazing stuff with that. I just showed animation, but we can do a lot of other stuff. MobX is a much simpler reactive. I would say it's in the FRP, it's only the R. There's not too much F. Yeah, so I would like to thank to Omer Spalter from my team that made that amazing game that you've played, that developed it. I'd like to thank Tali Ross also from my team that helped do the design. I would like to thank Doron Zavalevsky, P.P. Tayeb, and Benjamin Greenbaum for reviewing this tedious presentation and giving me nice comments about it. And very special thing, a very important thing, we are recruiting. This is my email. If you'd like to be part of it, we're really using the latest technologies. We're always thinking for improvement. So if you're a good developer, really, you're more than welcome to join us. And thank you all.